Just gets windier and windier. New balloon type.
Test, 1, 2, 3. Oh, there it was. All right, good morning, Clint ISD. Hope everyone is having a fabulous Wednesday today. I am Justin Yepes. I am from Instructional Technology, and here with me is my partner.
Hi everybody, my name is Gisela Lucero, also Instructional Technology, and today we're going to be here with you all live on this awesome Wednesday morning. And so we're going to be moderating the chat. We did leave the website on the chat in the comments. If you guys are on the YouTube channel, go ahead and go on to the comment section. Mr. Ryan went ahead and put the website on there so that you all can follow along. And back to you, Justin.
All right, as you can see, the link is right here. If you go ahead and go to this link or on the chat, as my partner, Ms. Lucero, said, you can go ahead and see the fabulous website that was put together for elementaries and high schools. And this is our weather balloon launch, and it is called Project Raw. We will be doing some live streaming of the actual event, and if it gets too windy and we can't hear, we'll go ahead and moderate and let you all know what is happening from the studio. We are currently at FME. This is where the launch site is going to be. So right now they are setting up over at the field, as you can see here on this fabulous map made by, I'm assuming, Mr. Ryan. We have the launch site. It's that big star. That's where we'll be setting up that weather balloon, and there will be some students viewing around it. Lucky for them, they get a front row seat to an awesome event.
All right, and also don't forget, if you guys have questions or anything that you would like to ask, you guys can go onto the YouTube channel into the comment section and ask away. Just keep in mind, we will be moderating it, so please keep only nice comments on the YouTube site. Any questions or anything you're curious about, you can go ahead and ask on there, and we'll be answering your questions.
And now we will be going ahead and taking us back out to the field.
Hey everybody, good morning. It is a little bit breezy this morning. We're trying to get the balloon all set up. It is, we're hooking up all the equipment this morning first before we fill the balloon, just because of the breeze. It's kind of breezy, so we're gonna have to cover it with a sheet of plastic while we fill it. But we're almost ready to fill. That's gonna take place here in just a couple of minutes. So super excited about the launch today. It's been over a year since we launched. We got some really cool experiments going up today. And so really all we have to do left to do is fill up the balloon and launch away. So, and that'll take place here in just the next couple of minutes. So stay tuned.
currently right now we are filling up this balloon. So if you're wondering what this plastic over the balloon is for, it's really because it's windy out here. We're trying to make sure that we keep the balloon down and it doesn't fly away as it's being filled up. You can see now this balloon's growing. It's getting bigger and bigger. We are no longer able to hold it down with the plastic that we were using over it. Stand right here. All right, and we have Agustin here, 5th grade. And Agustin, what are you thinking about this event right now?
It's pretty good.
It's pretty good? Awesome. How big do you think that balloon is? You seen a balloon that big before?
No, I haven't.
No, he hasn't. You excited to see it launch?
Yes.
All right, thank you, Agustin.
You're welcome.
us a countdown.
Oh, here we go. Here goes launch. And there you have it. As you can see, we have the balloon going up. Those two we have some boxes on there. On those boxes, we have cameras that will be collecting data for us based on how the altitude of this balloon is. Inside of the other boxes, we also have artifacts that students were put in there, things they wanted to test. I think they even put some roses. They hung some roses on there as well. So let's see what's gonna happen to these artifacts as they go and they continue to rise in elevation. As you can see, the further and further it goes away, the smaller and smaller that balloon looks. Look like one ginormous boulder in front of us. All right, and as that balloon is getting smaller and it gets harder for us to see, I will go from being outside to going back to the studio. I'll see you all in about 2 minutes.
All right, so I'm back in the studio now. It was rough out there, as you all could see. That wind was making it tough. We were having a struggle with that balloon, but we were able to get it up and going. And one thing I do want to remind everyone is to go to the website. Make sure you all can see all the data on there. In the chat, we also put the link for you all to get the data as well. I went ahead and pulled it up on my phone as well. So as we can see right now, our altitude is at 11,673. And you can see the tracker right behind me. You can go ahead and track where it is going on the map. We are also now at a speed of 6 miles per hour. When we started off, we were at about 36 miles per hour. That was, I'm not gonna lie, that was fascinating to me to see how fast we were going. Remember, please put your questions in the chat. We are moderating that chat. So whatever questions you have, go ahead and feel free, ask your questions. Keep on tracking all the data that is being pulled up on this stream for you. We are waiting on the fabulous Mr. Swanson to come into studio to share all of his amazing knowledge with that he has with this StratoStar, with his weather balloon that we have. But please ask all the questions that you have so that we can go ahead and answer those for you. And I hope that you all enjoyed seeing that launch. It was a lot faster than what we're normally used to, but we had to let go of that balloon real fast just because of the weather outside. That wind was really making it difficult for us, so it wasn't as easy for us to hold it, make it look pretty. We really just wanted to get that balloon up in the air and out of our hands as quickly as possible. So with that being said, I'm still tracking this. We're now at an altitude of 12,851 feet. Our distance, it's traveled about 2.4 miles is what I'm tracking here. So we'll continue to track this, and we'll continue to see what we have here. We're looking at the map here. As I look at the map, it's right above, going past the Agua Dulce area that I can see right here on the map that it's tracking. But yes, feel free, ask all the questions you have. So I want to point out and say thank you to Clint for always thinking of new and innovative ways to incorporate these amazing ideas with our education. They're always being the leading the charge with innovative ways of bringing the reality to you all. FME, thank you once again for hosting. As always, FME, we are appreciating all that you do for us, putting up the live stream, allowing us to use your field, and allowing us to do this amazing weather launch from here. Our mission time right now, we are currently going at 52 minutes so far in our mission time. So we're just about to hit the 1 hour time. We are about 8 minutes away from being at that 1 hour time frame. Our altitude right now, as you can see, we are at 14,012 feet. Our latitude, we are at 31 degrees. Our longitude is at -106 degrees. Our speed is at 7 miles per hour, and we are heading at 155. Oh, and just like that, our data just changed. So we are at 15,312 feet. 9 miles an hour and heading 155 and 8/10 degrees. Our distance traveled is still at 2.5 miles. Our vertical rate is at 1,299 feet per minute. That is very fast. That is very fast. So we are still here waiting on the fabulous Mr. Swanson. He's outside still finishing up with all the equipment that needed to get picked up, with everything that they were doing outside. Mr. Swanson's going to come in and he's going to share more of his amazing knowledge that he has with this. He's been doing this. He's probably been the one that started doing this and will continue doing this until we no longer have Mr. Swanson, but we are grateful for having him and all the knowledge that he shares with us. As we continue to track our data here, we are now going on 16,562 feet. Our latitude is still at 31 degrees. Our longitude is at negative 106. Our speed increased now. We are now at 12 miles an hour. So we went up by 3 miles an hour. We are, like I said before, we are right around the Agua Dulce. It's making somewhat of a curve right there, if you can see right over here. It started off right up here at Frank Macias, and it's curving its way down. We are right here on the Agua Dulce Ascension area. We are still going. Our altitude is at 16,562 feet, 12 miles per hour. And we just got a report. We will have the fabulous Mr. Swanson in studio in about 5 minutes. So go ahead and keep track of this data. Keep this on your flat panels. Keep this on your computer. Make sure you comment. Send in some comments. We'll go ahead and answer those. And we will be back with you all once Mr. Swanson arrives on studio.
Time to make predictions of how high
Oh,
altitude was.
and make sure you make your predictions. We want to know your predictions, how high you want to go, how high you think our altitude will be. So go ahead and make sure that you make those predictions, and we will get back with you once Mr. Swanson's in studio.
in space.
All right, you're on. It's you.
Hey, good morning, everybody. It is great to be with everybody today. I hope that you were with us this morning as we launched the weather balloon. As you probably noticed, it was a bit of a battle. It is always difficult when the winds are get up around 10 miles an hour, and I think they were probably around 10, 12, 14 miles an hour. And right at the very end, it was quite the battle. But we were able to get the balloon off the air. It was super, super fun, super exciting, a little bit nerve-wracking maybe at first, but we did get that balloon off the air. This mission was called, by the way, maybe I should introduce myself. My name is Bill Swanson, and I work for the district. This is my colleague, Miss Oliver. She is the secondary district science coordinator. And we're here to talk a little bit about the weather balloon and some of the experiments that went up in it, and certainly answer any of your questions. And we're probably going to have some quiz things for you as well. So be prepared to sling out some of those answers. I hope there's somebody getting ready to type some in as we're speaking. This particular launch was titled Project RA. And I'm going to let Miss Oliver tell you a little bit about RA.
Hi guys, my name is Miss Oliver. So Ra was an Egyptian god, and he was one of the first Egyptian gods to come on the scene. And he was responsible for several things, but first, he was responsible for the sun. And so as he traveled across the world, he carried the sun on his, it's not a crown, what do you call it?
Headdress?
Headdress, thank you. He carried the sun across the world on his headdress. And then as it became nighttime, he would go into the underworld and he would fight the demons of the underworld all night and slay the serpents. And then when it was daytime again, it was because he had won his battle in the underworld. So we named this Project Ra because we wanted to symbolize our mission towards the sun.
Anyway, so that's how we came up with the mission name. And so the balloon right now, if you're following along, is right at, hey, what's our altitude? Someone help me out right there. Yeah, we're going to switch real quick to our view and our data view. We are just over 35,000 feet, which is amazing since we just launched. If you notice, it is headed towards the west. And actually it's backtracking a little bit, and you kind of expect that to happen because of winds up in the atmosphere. And let's see, what else do we notice on there? The speed is 32 miles an hour, and so far the distance it's traveled has been 70 miles, so it has traveled a good distance in the last half hour. So it is moving pretty rapidly.
Very.
Anyway, so I know that there were a couple questions. Somebody asked how long we've been launching weather balloons in Clint ISD, and I believe it's been 5 years, 6 years. 6 years, I believe, is how long we've been launching weather balloons. We didn't launch too many the last couple of years, but this coming year we are planning on launching. We are planning on launching 3 weather balloons. So I hope that you're going to join us this coming year as we launch. And I hope that you're able to follow along with us today as this weather balloon makes its track and lands out here somewhere in West Texas. We believe that the balloon's going to land somewhere over towards Del City. Doesn't look that way just yet, but that's where our prediction had it landing. And so that was another good question that somebody asked. Was that from?
Red Sands.
So Red Sands asked the question. Red Sands asked the question about how much the balloon weighs. Well, one thing that I can tell you that's kind of important, because the gas that fills the weather balloon is helium, and helium is lighter than air. So helium is going to lift. And so whatever was in the balloon had to overcome the weight of the things that it was carrying. And so we had experiments and we have instrument packages that the balloon is picking up and carrying. And so those instrument packages in total probably weigh maybe about 5 pounds. So the balloon with the gas probably around 9 to 10 pounds would be my guess. So it's not very heavy. In fact, super light enough where it can pick up those objects and carry them off into our upper atmosphere.
99,000 feet.
Oh, okay. Oh, so she's predicting it right now. Okay.
I predict.
So it's a little bit early for this, but I'm always up for a little bit early. So Miss Oliver is predicting that the balloon will pop at 99,000 feet. I'm asking the students out there from your class, send in your prediction. Where do you think? I'm just going to tell you, I've never been wrong about my prediction about where it.
Okay.
I have never. It's never happened. Mr. Swanson is always right. I'm going to tell you 99,000 is a really good guess, but sorry, Miss Oliver, I'm not going to agree with you. I don't think it's going to pop at that altitude.
What do you think?
Yeah, I'm thinking about a number, but I'm going to allow the students, because I don't want to say anything until students and classrooms have a chance to chime in. If you have a guess, or your classroom has a guess at how high the balloon will go before it pops, please type that up in the chat, send it in, and let's see who's going to be the winner of the best guess. Again, I think it's going to be me. Miss Oliver thinks it's going to be her. No. Miss Oliver thinks it's going to be her guess of 99,000 feet, and so we'll see.
We can tell them about the experiments.
All right. Yeah, let's please.
Yes, so we have a few experiments. Oh my gosh, we just had some major movement right there on our screen for the travel. Yeah. It did? No, oh sorry. So our altitude is 42,674.
So 42,000 feet. So that is above, it is above any planes. Planes typically fly no higher than about 41,000 feet at the maximum, and most of the time they're between 32 and like 39. So that's above any plane, so that's pretty exciting. So our balloon is higher than any plane flies, any commercial plane anyway, so that's pretty interesting.
But back to our experiments, because I digressed. Squirrel. So our experiments, we have a few experiments that went into space. We have seeds. I know we have done seeds in the past. However, this time we put them outside of the box. So we have our control seeds, which are here probably in one of Mr. Swanson's pockets. And we have our seeds that we sent on the outside of the balloon. We tied them to the strings that are slightly below the balloon itself. Another experiment we sent was roses. So we have our roses again tied to the outside of our boxes, so they're exposed to the elements just to see what happens, and then when they come back down we can compare them to the roses that came from the same bunch. Again, it's very important to have controls with your variables. Another experiment we sent was with sound. So we sent a cell phone into space playing some nice jazz. Who was that was playing? Frank Sinatra?
My buddy Frank here.
Frank
Sinatra. A little
Sinatra?
bit of it for you.
Okay.
Just because we can.
All right.
1 second. Let me pull that up. Here we go.
We're not going to Jupiter or Mars. Well, there you go. So we sent that up into space. So we have our speaker inside of the box. Speaker was on the outside of the box, I'm sorry. And the phone was on the inside of the box. No worries, it is super secure. We strapped it down several times. And hopefully we'll see if the sound works all the way up there. Actually, you can make predictions about that. Do you think the sound will stay consistent the entire travel all the way up to, well, my guess, 99,000 feet? Or Mr. Swanson's guess,
coming soon.
Keeping a secret. So put that in the chat box. Let us know what your campus thinks.
So Miss Parada's class predicted.
Miss Parada's class predicted.
First prediction, 100,050 feet.
100,050 feet. Woo!
That's That's a good one.
Their second prediction.
And a
was
second one.
255,000.
Oh.
255,000. That would be amazing. I would love to see that myself.
I think that would be out of this world.
Miss Barrios' class.
Miss
for
Barrios?
110,000.
110,000.
Okay.
Hey! Pretty soon I will tell you my guess. As soon as it pops, I'll tell you my. No, I'll tell you sooner than that. I'll tell you sooner than that. So let me just tell you a couple of other little details about. Well, I'm going to expand on the sound experiment, which was designed by some students in the ACE program, the after-school program at Horizon Middle School, and they came up with an idea of the sound one. And because we're able to communicate here on planet Earth, yeah, awesome. But if you're in space, can you hear noise or sound coming from someone's mouth? Well, the answer would be no, because you're able to hear voice because our sound, our vocal cords are vibrating, which makes the sound that travels through this medium of air around us. But when it gets up to 100,000 feet, there's not much air up there. So we're kind of curious if we're going to be able to hear the sound the same as we do here on Earth. So the balloon goes up, takes the cell phone and the speaker, and we have a camera there that's capturing the video portion. So we will be able to tell if the sound sounds the same or if it's degraded. So that'll be kind of interesting piece. Two questions.
Yes.
Question 1 from Miss Parada. Does it make a difference with the color of the balloon?
Which balloons? The balloons we attached or the weather balloon itself? Okay.
Does it matter the color? And 2, why do you choose white and not another color?
The balloon?
Yeah, the balloon, the actual weather balloon.
Okay. So that is a really good question about the color of the weather balloon. And my answer to you is it's in the way that it is designed. And the color is particular because if it is a particular color, then it is going to absorb heat at a different rate, and it's going to affect how the balloon rises in the air. So we wanted to make sure, or not make sure, but we wanted to ensure that we had the least amount of variables affecting the balloon. So white is, or it's really not white, but
It's a creamy color.
Yeah.
Either way, it should still reflect.
yeah, but, and so that idea is, that's how they're made and designed. In fact, quite honestly, they even put like a little bit of powder on them. You know, we really don't talk about that much, a really good question, but there's a little bit of powder on it, baby powder like substance, so to protect the balloon as it's being packaged. In fact, one of the things that we don't do is we don't touch it with our hands because the oils from the hand make the balloon more susceptible to popping. So we have to be very careful with that. So if we ever touch the balloon, we put on gloves.
And if you watched the live launch, you'll see I had gloves. Everyone that touched the balloon had gloves, you know, unless, you know, because it was a fight. So some of us were trying to, you know, just shield ourselves. I think some of us lost the battle.
And here's a really another interesting part about one of the experiments. One of those experiments didn't even come within the district. This is the first time that's ever happened. But we had a neighboring school district, a couple science teachers at a middle school asked if we would be willing to send up a couple of roses. And I thought, what a really great idea. But that's from Tornillo Independent School District, their intermediate school. I believe it's Coyotes. So way to go, Coyotes! Thank you for the flowers, and we will certainly send the data and your flowers as soon as they come back to Earth.
They're asking Mrs. Durant's class, what else is in the box? Was it only cell phone?
It was the cell phone and...
So, what else was in the box
The cameras.
is a great question as well. Most of the stuff that we had this time was on the outside of the box, and I wish I had brought one in with me. Maybe I can go get one in a minute to show you. But the boxes are kind of like little ice chests, you know, so, you know, actually you could probably put a couple soda cans in there with a little bit of ice, you know, and keep that cold, or water bottles. And because, again, when you go up to 100,000 feet, a lot of things change. And one of those things is temperature and pressure. And if you want to see how temperature or pressure is going to affect something, you don't necessarily want it on the inside of the cooler, you want it on the outside of the cooler. Or either that or you drill or make holes inside of your cooler. And so this time, a lot of the stuff that we put was on the outside. So the only thing inside the box was the secured cell phone. On the outside of the box, we had a speaker, roses, we had two different kinds of seeds. We had radish seeds and
Pinto beans.
And then we had roses. And so that's, and we also attached a little tiny balloon. So the school colors here at FME are blue and
yellow.
Blue and yellow. So we sent up a blue and yellow balloon that's on the outside. And so one of the things that happens with the weather balloon, because again, a tremendous amount of pressure down here on Earth, the balloon's about, I don't know, maybe 8 feet across, maybe 9 feet across. And when it reaches an altitude of 100,000 feet, it starts expanding. It gets bigger and bigger and bigger because there's less pressure. And so when it gets to its ultimate altitude, it could be almost 40 feet across. If it's 40 feet across, it's getting pretty close to popping if it hasn't already popped. And just gets so big that boom, it pops and then drops back to Earth. In fact, let's check to see what that altitude is now.
You know, Mr. Swanson, I think you kind of dropped a hint there if people were listening. You told us you weren't going to tell us your prediction. However, he did just kind of hint at when it might pop. I don't know.
They're asking, how far do you think it'll go? That's what they're asking.
How high?
How
They're
far?
asking your prediction, Mr.
How far
Swanson.
did the balloon go? Or has it gone?
Oh, well,
Where do you predict the balloon will land?
currently, what's that say? Say
55,128 is the altitude.
Yeah, and how far has it traveled?
14.2 miles.
Oh, 14.2 miles. So obviously I was
Wow.
wrong earlier.
I thought
so
it said
it's traveled
142.
just around 14 miles, so it's not too far away. Maybe we'll drive over and pick that up here in a minute. So at 55,000 feet, could you do another thing for me? Can you click on the sensor data? And so here's one thing that's kind of interesting. If you notice, it is just under -8 degrees. So at 55,000 feet, just under 8 degrees. The PSI is 1407, humidity is 6, turbulence is 45. And can we click on, is there one for the graph data? I think if you scroll up maybe just a little bit, see graphs? Thank you. And so if you look at these particular graphs, what you're going to notice is time versus altitude. So you notice those first dots going all across the bottom, that's when it was still on the land, it hadn't taken off yet. But if you notice, it has a nice straight linear curve as that balloon is taking off, which is really kind of interesting. So that's altitude versus time. And I need to make my prediction here pretty quick because, yeah, otherwise people probably, yeah. But again, I'm just going to say, I've never been wrong.
You know, now that I'm looking at the graph, my 6th graders and my physics experts should be able to tell what type of graph this is. You should be able to calculate a few things with this graph.
I would say so.
I would definitely use this in the classroom as a test question.
You can find the slope on that very easily. So, before I make my prediction though, let's look at the temperature if we could. And so look at that, which is really kind of crazy. So you notice that the temperature is right around in the 80s, right when it's still on the ground. But as soon as it takes off, what's the very first thing that happens? The temperature decreases. In fact, it decreases pretty steadily. They call that, the science term I think is adiabatic temperature change. And I think they typically say between 1.5 to 3 degrees per 1,000 feet. So the higher you go up, the colder it gets. But there's a limit to that. You get to a certain point where then the temperature changes. And why? Because the atmosphere isn't as thick. So the temperature drops, you get to a certain part in the atmosphere, and it changes. So you notice that there's a little curvature down there around, I don't know, what's that, minus 10, 12, somewhere?
Yeah. Minus 11.
Yeah, about -11, 12.
about minus 11 or 12. We can also look at the humidity. And you can see what happens to the humidity as we go up. So notice when we first were launching, it's bouncing around a lot, but you know, if you look at the average, maybe the humidity is right around 13. And as it goes up, what happens to the humidity? It drops. And so when we're sending up the pinto beans, those, you know, it may not seem like it, but those beans have moisture in them, and so does the radish seeds as well as the roses. And so what's going to happen to those things when the humidity drops? Is moisture going to be pulled out of those seeds? Will it be pulled out of that rose? That's one of the things that we're going to find very interesting, as well as the temperature and speed.
What do you think is going to happen to the foam inside the box?
Oh, so the question is, what's going to happen to the phone inside the box? What do you think, ma'am?
It's going to be well protected. I don't think anything's going to happen to the phone. As we've talked about the temperature. Your phones can survive. It's an iPhone, so it can survive in water. It can survive in cold temperatures. It can survive in hot temperatures, so it's okay. And as you've seen, the temperature's dropping, so we're safe there. And with the landing, still again secure. Remember, it's a styrofoam container, so it should be able to take a nice hard fall and be okay. I'm not worried. Are you worried?
No. It's going to be fine.
I'm still kind of sad. I wanted to send my cell phone into space so that way I could tell people it was out of this world.
That would have been awesome. Wow. Anyway, so jumping back to the data screen real quick, you know, that gives you a sense about the time versus the speed. And yeah, I can't tell you a whole lot about that. So, you know, you can tell though that the speed has been increasing. Do you mind clicking on the
You know, our physics students and our 6th grade students should be able to dissect completely this time versus speed. That's a standard that they've covered already this year. They're masters at this.
Awesome.
Another test question.
And vertical rate. And again, giving you a sense about how fast that thing is going up over time, and then pressure. And so that's one of my favorites. But if you notice that we have right around 13, right when we have 13, and then all of a sudden we send it up, and look where it is. It is getting close to 0. In fact, right now it's right about 1. So what is happening to that balloon? It is expanding like crazy just because of altitude.
At a constant rate because of the nice curve.
Yep. Thank you. Hetty?
Physics knows.
This gives you a sense about its direction. I will tell you that is, my understanding, that is in degrees. So that is based off of a north heading. So yeah, spin rate. And that gives you a sense about how much craziness is going on up in the air, how much, to some extent, turbulence there is in the air. And finally, the battery. Okay, so our battery's time. Hang in there, battery. The last one, the turbulence. So this one is also kind of interesting because as the balloon is rising, we have different air columns up there. So what's the air column that's closest to the Earth? Anybody know what that's called? Or how about when it gets up to where it pops? And we call that area the stratosphere. In the stratosphere, so I'm sorry, let me just say it then. In the stratosphere, one of the things that we go through is forget the name of it, column of air, jet stream. So we have the jet stream up there, and that can range anywhere from 30 to 60,000 feet. And so when you see a lot of turbulence like we do at, I don't know where that was, 40, 50,000 feet, you can get a sense about where that jet stream is. In fact, the Weather Service here in El Paso sends up weather balloons pretty regularly that checks that kind of information. They don't go out and recover it, they just send it up, and they call those things radio songs. So They do check weather that gets sent back to them that they can recover to talk about things like the weather and temperature and upcoming weather patterns, as well as locations of that river of air up above that's going super fast called the jet stream. Hey, do you mind going back to our main page? Oh, yeah, to maps, thank you. And we are,
Well, it's on me. There we go.
coming.
Satellite.
Almost here, everybody. Let me tell you, so while we're waiting, let's see, we're almost there. It is updated. Do we have an updated altitude? Uh-oh, uh-oh.
69?
We're at 69,000 feet?
68,045.
68,045. It is now officially time for me to make my prediction. Anybody else have a prediction before I make it? Okay, here we go.
All right.
I'm just going to say, Mr. Swanson's never been wrong. That balloon is going to pop at 94,780 feet.
Very specific, Mr. Swanson.
Yep.
Can you tell us why the extra 780 feet?
That's just what's going to happen, ma'am.
Okay. He says just trust him.
Okay, wait, we had another prediction.
96,500.
Ooh, who
Mr.
said that?
Yepes made a prediction at
96.5.
96.5. Okay, so one of our technology gurus is predicting 96.5. 96.5.
Oh.
We'll see we'll see. But you can trust me, my number is a good number. My number is a good number.
What city is it looking like we're over right now? I know it says we're close to Grace Chapel of the Fisherman Ministry, but what city is that in? Can we change the view?
Can we change to the satellite view? And zoom out just a little. It is on its way towards Del City. And again, we're at 68,000 feet. And do you mind switching back to a data view real quick? Thank you, I appreciate it. You guys do great work. Great work. We have great people here. So in terms of our data view, or our graphs, I mean, and so we can see that altitude. If you notice, that one's updated already. Now it's what, 75,000 feet?
Yes.
And what do we have in terms of the temperature? Oh, there it is. What did I tell you?
What?
So temperature dropped, and now it is increasing as it gets to that upper atmosphere. And so, again, after all the stuff we talked about, why do you think the temperature is increasing now?
And it's exactly at 10 degrees Fahrenheit. We left the negatives. We went from negative 10 to positive 10. What do you
Changed
know?
by 20 degrees all of a sudden. Why is that? Why is that? So, I will tell you what I think it is. I'm sorry? Okay, please.
No, I'm saying it's getting close to its altitude.
Oh, one person wrote it's getting close to its altitude, getting ready to pop. I'm not so sure about the popping part. Look at that. The data changed again. Now it's almost 20 degrees. It is crazy about how that temperature changes. And so my prediction is it is going through different layers of the atmosphere. That's why we're getting that temperature change. In fact, it very well could be related to maybe not the jet stream, but maybe. We'll have to go back as soon as we get all the data and look to see. But I find that very interesting. And just one last time, do you mind clicking on the humidity? Oh, yep. I don't think it'll drop tremendous amount more, but okay, I'm ready to go back to the main page. Thank you. Maps. Thank you, the data. And according to that, we are at 76,000 feet. Didn't it just drop by 1,000?
Yes.
It did just now.
Okay, that's a little
Oh, no,
bit
it just went back
strange.
up now. It's 79,072
There we go,
feet.
79,000 feet, just amazing. So let me see. My prediction was 94,780, so 80, 90, so another 27,000 feet, that balloon's gonna pop. Okay,
According to your prediction.
Question. In the past, how long does the balloon last until it pops?
Do we remember last year's?
so I assume from when it takes off to when it pops.
Right.
And so that is typically about an hour and a half from launch to pop. So it is 10:09. We launched about 10 after 9 maybe.
Yeah.
So yeah, we've been in the air about an hour now, and so it'll probably be up in the air maybe about 20 more minutes, maybe 30, and then it's going to pop and come down. And it is going to come down super, super fast. We have a parachute on the balloon, and it is maybe, I think, a 6-foot diameter parachute. But as that balloon comes down, again, there's not much atmosphere up at the upper portion, so it is going to come down straight down until it gets enough air underneath the chute to open, which is maybe around 20,000 feet, somewhere in there. Chute's going to open up, and then it's going to slow it down, but it's still going to come down like a rocket. So that's pretty interesting as well. So there's certainly a lot to learn about weather balloons and working through this process.
Another question from Mr. Rath's class. Does the temperature affect the battery life of the balloons?
Ooh. Well, if you think about a few of the experiments that people have completed in the past, what happens to batteries when you put them in the refrigerator or the freezer? Why do people put batteries in the refrigerator or the freezer? Do you guys know? Never? No?
To check how they work in different areas?
Well, some people have put batteries inside of hot cars, and then they have a control battery that they keep in their home, and then they have some batteries that they put in the freezer. And according to experiments, the batteries that are put in the freezer are supposed to last longer. So I'm wondering if it will save our battery from dying before it comes down.
100% when you sent it off? It was on?
Everything was brand new. Oh, the
phone.
yes, it was on.
On and 100%.
Did you charge it at 100%?
Affirmative.
Oh, okay. I'm like, oh my God, this is a good time to ask.
So our phone battery was at 100% when it went off. The speaker was at 100% when we sent it off. The Bluetooth speaker and the our SATCOM box. If you watch the launch, it's the yellow box. It was at 100% as well. But 100% for that one it's like a 9.2 volt battery, I think. So when it's fully charged, I believe it's 9.2 volts. And so right now, the last time we checked, I think it was down to 7.8 volts. And it'll be down in the ground a little bit. We'll get the coordinates to where it lands, and then we're gonna run out there and pick it up real quick. And if you notice off this screen, it is looking like it's heading parallel to Route 62-180, is that right, 62?
Yes.
Yes.
62-180, that's the road that takes you to like Carlsbad Caverns. And if you see that little green area up the upper right-hand part of the screen, that is Del City. The winds out of El Paso or in the southwest area are westerly winds. That means they blow from the west, and so that typically means things go towards the east. So when we launch from here, the balloon typically goes towards the east. So if you look at our map, can you scroll a little bit more to the left so we can see the path of the balloon? If you notice, it looks like it's headed almost due east from where we launched. Yeah. And it's gone, looks like it's traveled about 18 miles.
Yeah.
So that's pretty exciting.
Well, the speed has picked up, Mr. Swanson. It's been at 9 miles per hour for a while, and now it's at 15. So.
And look at that altitude. Where are we at?
Close enough to my number.
82,000. I'm just going to say it's going to pop in about 13,000 more feet, and then I can be declared the winner again. Woo!
Another question.
Yep.
Oh,
In
you
the
lost
past, what locations have the balloons landed in?
Mm.
There's a very predicted science so that we do not have to go above and beyond the state of Texas as far as possible to retrieve our weather balloons. But Mr. Swanson, you've been doing this for like 6 years.
Yeah. So a lot of times it lands right where you would expect it to, somewhere around Del City, around this road, 62 180, and we go out there and pick it up. There are a couple times, one time where it landed over near Blue Origin, which is the Jeff Bezos, I believe. He's the one who flies Blue Origin, but he has rockets out there that will take you up into space. And so it flew over there into a property. In fact, the property it landed on was one of the largest landowners in the state of Texas. He gave us permission to enter his property to go pick up the balloon, so that was pretty awesome. And one time we had a technical difficulty in the launch, and the balloon landed over near the panhandle of Texas. And so it took about 4.5 to 5 hours to drive to get it, and then 4.5, 5 hours to get back to El Paso. That was a pretty late recovery, but 90% of the time it lands somewhere around towards Del City. So, and it looks like that's what's going to happen this time. And we are at 88,000 feet. Woo!
So when it goes past the 94,000.
Man.
Listen, I'm trying to give Miss Parada's room hope. They have 100,000 and 255,000. I'm cheering for them as well.
Yeah.
Oh, and Miss Barrios with 110,000. So we
I'm
just
just
need to
gonna
get
say-
past him.
Look at the map.
Oh yeah, look at that. Wow, that's a little bit crazy. Hey, I'm going to tell you, we have never had a weather balloon go over 100,000 feet. So quite honestly, I'm cheering for Miss Parada as well. I hope I'm wrong, but if it gets over 100,000 feet, this will be the first time that has ever happened. So Miss Parada, Miss Barrios, I am with you guys. Let's make that happen.
And when it happens, we'll sing the song. For the first time in forever. I'll sing it with you. I'll be the first one.
Hey, do you mind changing back to the other graph since it's getting even higher? Oh yeah, to the altitude one. Okay, you can see right there, again, everything looks very linear, just like you'd expect. We have a very constant uplift or lift. Okay, and now temperature. Oh yeah, look at that. It is
32, looks like.
Yeah, it looks around 32 degrees. So right at freezing at basically 90,000 feet.
Getting cold.
Yeah, in the cold. Ooh, man. Do you mind clicking on the very last one, the turbulence? Yep, and do you see right around that 80-minute mark to the 85-minute mark? Can you click back to altitude again real quick? So we have that little peak there. So if you look at that 80 to 85-minute mark, we're right around 50,000 feet. So I'm going to tell you, that's where the jet stream is.
Yep.
So you can tell just by all that turbulence in that area, it went through a pretty rough patch of weather. And because of that, in fact, so now let's click on the temperature again.
I'm wondering what the spin rate was right there during that time frame too of 80 to 85.
And you notice that's one of our coldest in that jet stream, it looks like, probably right in that area.
That's the spin rate.
Yeah, it's spinning like crazy. Woo! Okay, let's check our altitude again, because I'm getting ready to win.
91.
91,000 feet. Uh-oh.
You have to refresh.
Yeah, refresh,
Refresh
please.
my went to 91, 325.
91,325. Awesome. It is so getting there. Not only did we send out that weather balloon, I will tell you that we have several patches on the balloons. So several schools contributed patches. So I know there are patches on there from Frank Macias Elementary. I know that there are patches on there from East Montana Middle School, and I know that there's patches on there from Horizon Middle School. And so, which is pretty exciting too. So again, those boxes have gone up to a place where very few human beings have ever been. In fact, probably if you had to think about it, how many human beings have been above 90,000 feet? What would your thought about that be?
I don't know. I don't know the name of every astronaut. Neil, Buzz. Wait a minute.
Buzz Lightyear? Nah, just kidding.
Man,
Buzz
did
Aldrin.
we take? We should have put Buzz Lightyear on there. Next year, guys, we're putting Buzz on there. That's the idea. Mission Buzz Lightyear
To infinity and
beyond.
Anyway, so
How many people?
95.
so fewer
Oh,
fewer than 1,000 people would be my guess that have been above, because there are quite a few astronauts that have been in space. So here, let's look at that number. 95,450.
oh no, it's updating. It's 96,988. Guys, Mr. Swanson's prediction has busted. Boop.
Oliver, you're getting closer.
Yes, we are.
I'm just gonna say, there's always a first for everything, and I'm with Miss Prada now. 100,050. You go, ma'am.
We're getting there.
Best day ever day. From a rascally launch to maybe our all-time highest altitude. So we'll get to see here pretty quick.
Yes.
I'm sorry, ma'am? It was 90. So last year's balloon, because we did launch one last year, it was 99,980 feet, something like that. So amazing.
We're getting an update. It's still going?
Still 90.
Speed is 13, so it's still going? Okay.
Awesome.
We were worried for a second. Sorry, no need to cause panic.
I'm not worried. I'm super happy.
I'm just going
100,000,
for
100,000,
99,000.
100,000. And it's a candy bar too.
It's at 98,520.
98,520. We're getting close, everyone.
And so as I think about that, I'm wondering what's happened to the roses that were attached to the outside. I'm wondering what's happening to the balloons we put on the outside. I'm wondering what's happening to all those experiments. I'm wondering if we're still listening to Frank Sinatra at 100,000 feet. I wonder how many times Frank Sinatra has been played over 100,000 feet.
We would
My
have
guess
to
is
know.
probably the first, right? What would you think?
I'm pretty sure some of
Oh
our
no, come on, ma'am.
some
We're
of
the
our
first.
grandfathered in astronauts probably played Frank Sinatra.
I don't know what you mean by that, ma'am.
I'm just guessing.
Okay.
It's just my guess. My prediction is going to be that next year Frank will go up again.
Awesome.
100,157.
Oh my gosh, no! Miss Prada, like one of your guesses, it's gone just as much as mine. It's okay.
I think Miss Brown is going to be closest.
No, Miss Barrios has a really good chance at 110,000.
This is the first time ever. Wait.
100,000! I think we should make a more than Mile High club. 100,000 club. Yes, 100,000 club.
That's
We
the
need
first time.
T-shirts. T-shirts that say 100,000 club.
There you go.
Over 100,000
Yes.
feet. Yeah, that is crazy.
Thanks to Miss Barrios. Right here,
First
just right
time
at the bottom.
ever. First time ever. It makes me so happy that happened.
Maybe it was because we fought the balloon before it went up.
Yeah, could be.
I think just the stretching and the fighting and shielding ourselves, that may have been a contributing factor. Please put in the chat box if that's what you think happened.
Oh yeah, 801.
It popped.
It did?
Yeah. See the little dot on there?
It's got little spikes.
Yeah. Ladies and gentlemen, boys and girls of all ages, the balloon has popped. It is now descending to Earth.
And the maximum
And so-
altitude was 101,801 feet.
Yeah.
Wow,
So,
that
yeah,
was a lot.
First time ever that it reached that altitude. Jump back to that data page. You can tell that it popped because the little spikes on the balloon itself. And can we take a look at it? Thank you. So now we're looking at that particular screen. And notice it has already dropped to, what is that?
95,000.
Yeah, so it's already dropped 6,000 or 7,000 feet. So
In
it
just
is
a few
coming back to Earth
seconds.
very rapidly. Hey, what's that force that makes things come back to Earth? What do we call that again?
Ooh.
What is it? I don't know. Anybody know out there? That
Put
makes
it in the
things
chat
fall back
box.
to Earth? I'm trying to remember that force.
Starts with a certain letter. Maybe a G?
G, maybe.
Can we just call it G-force?
G-force? Okay.
Okay, G-force it
Hey, did
is.
someone put that in the chat? What's that force called? That makes things fall. If I drop this, it falls. Okay. And so now we're looking at that time versus altitude. So you can see it was going up and now it is coming down. And the interesting part is going to be this particular curve. So if you're looking at the data, if you're following this mission on this page, to keep an eye on this sheet, because the speed that it drops is going to be way, way faster than the speed of it going up. That was a nice steady curve going up, and it's going to be a pretty steep one coming down. And then probably right when it reaches around 20,000 feet, it'll lessen a little bit, but it's still going to be a quick drop.
I'm wondering if we come down that fast, what is going to happen once we hit that jet stream at 30 to 40,000 feet like you were mentioning earlier? Maybe you can make a prediction about that as it falls down.
Yeah. We could do that.
Me?
Phone call.
Oh, yes.
Pardon me.
You guys are
Miss-
still on?
Yeah.
We are? Are we?
Yeah. Yeah. No sweat. Miss Oliver is going to step out for just a moment. She's going to make a phone call.
Yes.
We do everything by the rules. The FAA needs to be contacted, so she is going to make a call to the FAA to ensure that we are complying with their policies and procedures. But again, if you're looking at this time versus altitude, if you notice how steeply it is coming down right now, in fact, its altitude is it altitude just over 80,000 feet?
72,723 feet.
72,000. So just in a matter of a few minutes, it has dropped 30,000 feet. 30,000 feet, ladies and gentlemen. That is crazy. So if you kind of think about it, the parachute isn't holding any air, so it's just dropping out of the sky. Hey, did anybody write in the chat what that force is called? Trying to remember.
Refresh one more time.
Any comments? Come on, team.
Checking on those comments for you.
You're
And-
watching?
Okay, so it begins with a G. Begins with a G. Causes things to fall if you drop them. Boom. And now we're down to 60, right over 60,000 feet, so it's dropping pretty quickly.
We're at 63,000.
Yeah, right at 63,000. So it is not going to land exactly where we expected it to. I thought by our prediction it would have landed closer to the road. So it looks like we may have to do a little off-roading, maybe a little bit of hiking. We got a team of people here that's ready to go hiking out in the wilderness, looking for snakes. Okay, no, I'm kidding about the snakes,
Been
but
there.
yeah.
I think Kevin wanted to go with it.
Anyway, when we get out there, one of the interesting things is not only just looking at the experiments, but we also have an opportunity to pull data off of the equipment. Because online it said that we were at 101,200 feet. What's that? Somewhere in there, just over 101,000. But there's data that actually shows exactly on the instrument package exactly where its peak altitude was. Because this gets updated by satellite every minute or so. And so if it went up higher in that minute before it popped, it may be a little bit higher than we think. And again, look how that steep drop off is compared to that slow climb. So we are already at, looks like maybe 57,000, somewhere in that neighborhood.
56.
56. And just for giggles, if we could jump down to in that data page where we're looking at the about the turbulence again, because remember that turbulence is kind of an interesting one as well, because on that turbulence page, oh, notice. So we're in that turbulence area again. So what do we call that before? We called that our jet stream. So it is hitting that jet stream right around that 50,000 mark, which is kind of an interesting piece. And again, that's what weather services all over the planet do. They send up weather balloons to check wind speed and check for where that jet stream is. Oh, and can you check a temperature as well? And so if you notice at our peak, we were right about, what is that, maybe around 50 degrees at 100,000 feet. And now that it's dropping again, the temperature is dropping. And so what we should end up seeing, it should end up looking a little bit like a W pattern. So it drops down to get to the coldest, and as it goes up, it gets warm again. As it drops, it's going to get cold again. And it should get down to around 0, -5, and then all of a sudden it's going to start, temperature is going to start increasing again if you're looking at that graph. But again, as it's going through the layers of air, temperature will change. So we will end up with the W. I'm really curious what's going to happen to the roses. Okay, what's our new altitude?
44,900.
44,900, so in the next 20,000 feet, we should see that altitude graph change significantly. Kind of waiting on that altitude graph should show, because right now it is dropping almost straight down, but once it gets to around 20,000 feet, it should start leveling off a little bit. Not a whole lot, but enough to slow it down so it doesn't damage our equipment out there in the field. Hey, any questions out there from the audience? And by the way, congratulations, Ms. Parada. Yours was the closest and made me super happy. First time over 100,000 feet. First time. And we're at 40,000 feet. So another 20,000 and we should see that drop off. Pardon me. In fact, maybe you can start seeing just a slight curvature right now. So, where is everybody logging in from? I see, is Ms. Parada, are you?
She's here at FME.
Oh, Ms. Parada, right here from FME. Awesome.
We have
And Ms. Barrios from Red Sands.
Mr. Rat from here, right? Oh, from here. Oh, from Mr. Rat.
Awesome.
When did it pop? What was the?
101.
101?
Yeah, 101 like 200. So yeah, I think in fact, put your mouse right there on the top of the blue dot, yeah. 101.8, yeah.
Yeah, 101,801.
Yep.
Oh, so I was right.
Man, that is incredible.
Mrs. Galvan from FME is watching too.
Okay. Awesome. I am so glad that you all joined us today for this weather balloon launch. And we're going to have another one of these, or this launch coming up early this coming year. So I hope everybody, that you would like to design and put your own experiment inside one of the payload boxes that we send to the upper atmosphere. So that would be super awesome. And that you would join us as well. But let's look at that data sheet one more time. We're at 35. So you can tell it's slowing down. It's not coming down as quick as it was before. Yep, so you can see it's starting to curve off a little bit right there around 30,000 feet. But when it gets down to 20, it'll slow down significantly.
Can we say the parachute kicked in already? Or not yet?
So the question was, are we saying that the parachute kicked in already? Well, what you can tell is it's starting to make a difference because as it's coming down, there's not a whole lot of air that it is catching underneath the chute. But again, when it gets down to 20, 15,000 feet in that neighborhood, it'll slow down significantly. So right now it says, what does its speed say? 20? Oh wait, is that the up-down speed though? I can't remember. We're at 27,359. The speed is 21 miles an hour. I don't know if that's horizontal speed or vertical speed though. But it certainly hasn't traveled very far. Oh, there we go, that bottom one. What's that vertical rate?
Negative 3,783.
So, and that's how fast it's coming down every minute, close to 4,000 feet per minute. That is crazy fast. Wow. Wow, 3,783 feet per minute. I wonder what that is in miles per hour. I'm going to check on my phone real quick what that is. 3,783. 1 second, everybody. Be patient. 3,783 feet. There's 5,280 feet in a mile. So that is traveling at 0.716 miles per minute, but I need times 60. We're traveling at 43 miles an hour. That's how fast it is dropping out of the sky. 43 miles per hour. That is crazy fast. And just at 23, so let's see how much that slows down. 30, yeah, let's update our screen. We are just under 20,000 feet now, 19,908. Slowing down some. So the question about the parachute, is it having an effect? You can see that it is because it's starting to curve. It's not just dropping straight out of the sky, but it is starting to slow down a little bit. But it's still coming down super, super fast. It should probably land, my guess is probably about somewhere between 10 and 15 miles per hour when it hits the ground. That is my prediction. We'll have to wait and see what happens. Yeah, let's see what that says. 3598, that is still coming super fast. Let's check, 3598 divided by 5280. So now it's traveling 41 miles, so it's slowed down 2 miles per hour. So it's still coming at a pretty fast rate. Wow, that's crazy. I'm sorry?
I said you can't drive a car out there.
Oh, out there?
Yeah, you're gonna have to take your truck.
So the question was about how we retrieve that. So we retrieve it following, believe it or not, Google Maps. And so we will drive out as close as we can, and then after that we hike to go get it. The most that I've ever hiked was maybe a mile, mile and a half each way. So maybe 2, 3, 4 miles round trip. A couple times it's landed right next to the road. In fact, I opened the door, could almost pick it up from the door. So that was kind of interesting in terms of recovery. Sometimes it lands on private property, so I have to contact the property owner. So sometimes that takes just a minute. And currently we are just over 13,000 feet, and the rate is 3177. Let me check to see what that is in miles per hour. My colleague is back, Miss 3177 divided by 5280 times 60. So now we're traveling at 36 miles an hour. It's already slowed down about 8 miles per hour. So still going pretty fast, and it should be significantly lower than that before it hits the ground.
We are clear.
Yep. Ms. Oliver was taking care of business with the FAA. Whenever you launch a weather balloon, you need to make sure you follow the proper procedures. So the Federal Aviation Agency and a man named Mr. Pilgrim out of Dallas and El Paso and Albuquerque are an intricate part of our team to make this happen.
Thank you, Mr. PJ.
Yes, thank you, Mr. Pilgrim. 3177 divided by 5280.
Oh, we're at 10,000 feet. Crying faces.
And which is how far off the ground? Maybe 5,000 feet off the ground, because we're at an altitude of around 4,000 or 5,000.
So yeah, we don't have that much longer to go.
Yep, it'll be on the ground soon.
Road trip. It's gonna be fun times, guys. Fun times.
Have a fun hike.
Mm-hmm. Okay, here we go. It's at
7,165.
and that vertical ray is 2984. Let's see how fast that is in miles per hour. Oops, you have to put it in right, Mr. Swanson.
The speed is 24 miles an hour right now, so.
It is traveling at 34 miles an hour. The vertical rate up and down?
Mm-hmm.
Okay.
We're doing pretty good. You know, the speed of the weather balloon right now is good enough for a school zone.
Aye, aye.
High school zone is 35
Okay.
in front of Horizon.
It is still coming down pretty fast. A lot faster than I like it to. I hope the parachute didn't get tangled in that mess.
Oh no.
Yeah. It has slowed down significantly though, so it must be at least partially working, but you would expect that number to be like around 1,500 or something, I would think. That vertical rate.
Ooh. We'll give it some time. We're gonna keep our fingers crossed.
Yeah.
Maybe we should cross our eyes too. Just for extra good luck.
Okay, I'm not sure I can do that. Okay. Well, as this is coming down for a landing, we certainly want to thank everybody who joined us today. It was our pleasure to be able to bring this to you. Ms. Oliver, myself, on behalf of our technology team, the people here at Frank Macias Elementary who helped allowed us to use their field for their launch, and the ENN network to support this broadcast so we can tell you a little bit of what's happening with this particular weather balloon launch project. Rah!
Rawr.
And let's see what our altitude is now.
I think we have to refresh.
Okay, coming.
Still.
Maybe it's on the ground. No, it could be that altitude. I wouldn't think.
I didn't see that we were on the mountains.
Actually, there.
I'm sorry?
Oh wait, I can't see.
There are mountains there.
Oh man, we're climbing mountains today. This is exciting.
So maybe that's why
It
at
is
71.
on a mountain.
Can
Oh wait, did that say Rattlesnake Canyon? Zoom back
Yep.
in. Oh yeah. Zoom back in. I just got excited, Mr. Swanson.
Snake tank.
It was the what?
Old rattlesnake.
Old Rattlesnake Tank.
Maybe a lake or something.
Oh yeah. Fun times. I'm ready.
yeah, let's check that data again one more time so we can look over there on the right-hand side.
It hasn't moved.
Okay, thank you.
Altitude is still the same.
Yeah, can
Well,
of the graphs?
Yes, thank you. Can you click on one of the very first blue buttons when it was on the ground here? So our altitude was right around 4,000 feet, and that last blue dot at 7,000. So yeah, it's probably up a little bit. Okay. Would you mind to click on the temperature one? So we're just checking the data, just making sure that it's on the ground. There's the W I was talking about. So I would expect that to be a little bit higher. So interesting. Hey, do you mind checking the battery for me? So checking all those things just to make sure. 7.8, we're still good on our batteries, so that's good news. And turbulence? That's an interesting number. I wonder if it's caught in a tree or bush and it's blowing around. Huh. Okay. Well, as I mentioned before, here we go. We launched this morning about 9:10. It is now 10:44. So we were in the air for about an hour and a half before it landed on the ground. And now it is time to go out and recover. As soon as we have some video of the recovery, we will be sending that out to everybody via the feed and the ENN network.
ENN News.
Yeah, ENN News. So anyway, I want to thank everybody for joining us today. I had a great day. Thank you, Miss Oliver.
This was awesome, Mr. Swanson.
Best day every day.
Oh man, we should sing the SpongeBob song. It's the best day ever.
Yay!
Thanks, guys.
Thank
Have a
you.
good
Bye.
one.
Are we up here?
Yep.
Awesome.